Hello, Mr. Price here, and this is the third video on the January 2007 Mechanics 2 paper. This one is on question 3, and we have another collision question, 2 in a row here, but this one is a slightly different situation. Let's take a look. So, we have a single smooth sphere of mass 0.2 kilograms, and it's projected vertically downwards with a particular speed from a particular height above horizontal ground. And this ball's going to hit the ground and rebound vertically upwards back to its starting position. Ignoring air resistance, we're being asked to find the coefficient of restitution between the sphere and the ground, and then the magnitude of impulse that the ground exerts on the sphere. So a two-part question here. Okay, now these aren't too strenuous if, as always, we just model our situation. So here's our initial condition. So our ball of 0.2 kilograms, okay, at a height for 40 meters above the surface, is being projected vertically downwards at 21 meters per second. And then what's going to happen is it's going to hit the ground here at a particular speed, and then rebound upwards with a particular speed back up to the top here, where we get 0 meters per second here. Okay, so in order to calculate the coefficient of restitution, we're going to need an initial velocity and a final velocity. So I'm going to call this UG for U ground, and this is VG for V ground, and we want to know these two values. Okay, and we have enough information here to do SUVAT. Okay, because we have an acceleration due to gravity, we have an initial speed, we have a distance, and we want the the velocity at which x is 0. Okay, so let's do this. So our initial speed is 21. Our final velocity is UG. Our acceleration, I'm going to resolve downwards, so everything's going to be positive here, 9.8. And it needs to fall a distance of 40 meters. So, using V squared equals U squared plus 2AX, we get UG squared equals 21 squared plus 2 lots of 9.8 lots of 40, and after some solving you should find UG to be 35 meters per second. Okay, so that's this here. Oh, sorry, not 30.5, 35. Okay, now don't be tempted to use any values for here. It's not going to come back up at the same speed. It's going to have lost some energy here. So we have to do a separate SUVAT equation to find this initial speed here. So here, its initial speed is Vg, and we're going to still be resolving downwards, so it's going against gravity. We'll resolve upwards for this one, so Vg will be positive, going against gravity. So our final speed is 0, our acceleration is negative 9.8, going against the speed, and x is 40, because it rebounds back to its starting position. So, once again, using V squared equals U squared plus 2AX, we get 0 equals VG squared plus 2 lots of 9.8, negative 9.8 lots of 40, and you should find Vg to now be 28 meters per second. So this is now 28 meters per second. And now we have enough information to find the coefficient of restitution. So we know that E is the separation speed over the approach speed. It's separating the ground at 28 meters per second. And it's approaching the ground at 35 meters per second. So E equals 28 over 35. So our coefficient of restitution is 0.8. Okay, and this is a dimensionless unit. Okay, now for the impulse, we do need to be a bit careful here because we do have a different speeds in different directions here. So we need to be careful with our change in momentum. So impulse is the change in momentum. And it's gone from 35 m minus 28 m. Okay, because they're in different directions. So overall, the difference between them is greater. So after doing that, you should find your change of momentum to be 12.6 Newton seconds, because we know the mass is 0.2. And that is it for question 3.